Meet Mr. Ng, our math wizard's grace. In numbers realm, he finds a space. Equations unfold with a skillful hand. In math class where understanding expands. Oh, Mr. Ng, numbers at your command.
Hey guys, this is your Quiz Corrections Integrated Math 3, quiz number 3, 2123, January 31st, 2024.
Question 1a, based on the graph, how many zeros does the polynomial function have? I'm going to answer this question in multiple ways, and I don't even need to use the graph. So, how many zeros? I'm actually just going to look at the degree here. The degree tells you how many zeros you have. In particular, here's an equation you had in your formula sheet, is the number of real zeros plus the number of complex zeros equals the degree. So if you have a fourth degree polynomial, that's how many possible zeros that we have. Okay, so the answer is 4. Here is a second way that you can figure this out using the graph. You can look at these green points, they call these turning points. Let's write that, turning points. They're kind of like the point in which you make a U-turn if you are driving. And the reason why they call these turning points is because I'm increasing, and then at that point, which is an extrema, max or min, in this case it's a max, then it turns to decreasing. So in this problem, I have 3 turning points. And the formula is the degree minus 1. So let's just say you don't even have a formula, you just have the graph here. You just solve for degrees. So I just add 1 and you'll have the degree to be 4. So a second way to show you how the answer is 4. And here is a third way that I know the answer is 4. You can look at the x-intercepts. So basically, zeros are how many times visually it crosses the x-axis. And if it shoots through or goes through the x-axis, then it counts as 1. So this, try that again. This is 1, 2, 3, 4. So that is a third way of showing you why the answer is 4. Okay, part B tells us now what are the zeros of the above polynomial function. Well, we can do this visually because we have not learned other methods. And basically, here on the x-axis, this is x equals -4. This one is x equals -1. This one is x equals 0. And this one is x equals 2. And so the only one that has that is choice C. Okay. This one works, that one works, this one works, that one doesn't work, so that's why it's not A. If you only have 2 of these and it doesn't tell you anything about multiplicity, then this would be a second degree polynomial. So not this one, and this would also be a second degree polynomial. All right, let's go over question number 2. Part A here says, which function has a local minimum of a value of -1? So if I go down to a y value, and I'm going to make my purple line there, does any of those graphs hit that purple as a low point? Well, the blue one does not, f of x does not. The g of x goes, that purple line goes through it, but it's not the low point. And if you look at h of x, here is a maximum. And then it goes this way and hits here. This is a minimum. There you have a max. Okay, so that means, which one of these? That would be h of x. Okay, part B. What is the minimum value of the g of x? So now I'm going to focus on the pink graph. And you'll notice in the pink graph that the low point here is this one. So I'm just going to highlight that, and you'll notice that the y value is -5. That was the clue I gave you guys. When you write the minimum, you are writing the y value. It's just a number. All right, let's move on to question number 3. Which function has 2 zeros? So actually the same graph as the previous problem. Which one has 2 zeros and an even multiplicity and a leading coefficient? Okay, leading coefficient basically says, you know, when the a value is negative. And what that does is it basically just, it reflects it. Let's write that, reflects over the x-axis. Okay, which one is kind of turned upside down basically? And the only one that has that is h of x. But let's confirm that with the other clues. It has an even multiplicity. That basically means that at the x-axis there is a bounce. That's what even multiplicity means, right? There is a bounce to the graph, right? It bounces off, it kisses the x-axis and runs away. So we have that in here and here. Okay, and then the last clue is there are 2 zeros, okay? And the zeros are x equals -2 and x equals +2. So that kind of confirms why h of x is our answer. Fill in the blank square so that each row and each column contain all the digits 1 through 4. Numbers and cages may repeat as long as they are not in the same row or column. So the darkened ones are a cage. So I need 3 numbers that multiply to be 24, 3 to multiply to be 2, 3 to multiply to be 6, 3 to multiply to be 8, and 4 numbers to multiply to be 24. Definitely use pencil. All right, so my strategy is I can only use the numbers 1, 2, 3, and 4. I like to write that down, super helpful for me. And 3 numbers that multiply to be 2. Well, I'm thinking of 1 times 2 times 1. And in the corner problems where you have to repeat a number, put those apart because they're not repeating in a row or a column. So I'm missing the numbers 3 and 4. So if I do 3 and 4, watch this. 3 times 4 is 12. 12 times something equals 24. That's going to be 2. Now I'm not quite sure if the 4 and 3 are in the correct order, so I can just keep going and then see what happens. 2 numbers that multiply to be 8. Okay, so I can choose 2 times 2 times 2, but those would be repeating numbers. So I'm thinking of 1 times 2 times 4. Now, if I put the 4, I can put the 4 over here, but that means I have to put the 1 and 2 here. So I'm going to try erasing the 4 and the 3. And just switching the orders. Now I can do something like 1, 4, and 2. 1 times 4 is 4, 4 times 2 is 8. And again, I can switch the position of the 4 and 1 later if I need to. Let's keep going. And you could have done this in multiple ways. I'm just showing you what I'm doing. That's the first time I'm looking at this problem. So I'm thinking to myself, 36 has to be like 4 times 9. 4 times 9. So if I get 4 times 9, that would have to be 4 times 3 times 3. Now you'll notice my repeating 4s here. So we talked about how I maybe just go back and switch these two. So I have 4 and 1. Okay, so that's 12, and then 12 times 3 is 36. Now I just need to fill this in. 4 numbers that multiply to be 24. And basically what I'm going to do here is think about where I can place the numbers in here. So notice how you have to have a 3 in each of these columns here. I'm missing a 3 here and here. I can't put the 3 here because it's repeating, so therefore the 3 has to go here. Let's see if we see some other numbers that are like that. How about the 2s? 2, 2, 2. We're missing a 2 here. Can't put a 2 there, so 2 has to go here. We're missing a 1, 1, 1, 1, so the 1 has to go there. And of course that one has to be the 4. Let's double check. 4 times 3 is 12, 12 times 2 is 24. All correct, you get 4 points, and then it's wrong if you get 1 point. Which function could this graph represent? Remember, look at your easiest ones. Easy. You have an odd, and you have an even. What are they? X to the first, X to the second. And that's what your graph looks like, right? So both arrows are pointing in the same direction, so I know it's going to be an even, not an odd. So evens, that means it's not these two. And then because it flips upside down, this is, you would have to put a negative. So that's a negative leading coefficient. We don't have that. Now I'm asked about extrema. So let's go here. Extremas, in this case, is a 1, 2, 3. We have 3 extrema there, and it is an even, so my answer is going to be D. Is the correct answer. Okay, answer is C. Question number 5. Multiple choice, which polynomial function r of x or t of x has a lesser degree? So let's take a look at it. I'm going to try to figure out what kind this is so you can graph it. -2, 15, -1, 6, 0, 1, 1, 0, and then right 2, up 3. So I'm not sure. It could be absolute value, but we can double check by our common difference. So let's do that. This would be -9, -5, -1, plus 3. If the blues were the same, then it would be linear, so it's not linear. So let's test now this one. -9 to -5 would be +4. -9 plus 4 gives me -5. +4 and +4. So this means it is a second common difference, which means it is a quadratic. If it's a quadratic, it means it's x to the second. So my degree here is 2. Let's test the other side. Now, you could distribute all the way through. 3 times this would be 3, x times x, you add the same base, 3 plus 2 is 5, and 3x cubed. My highest degree there is a 5, so I have 5 and a 2, therefore the highest degree of this problem is this one over here, and that would be t of x. Alright, question number 7. Which graph could represent the function f of x equals negative x to the third power minus x squared plus 5x? Okay, what I'm going to do is I'm going to just take apart this function and try to figure out all the things that I know, okay? Here in blue, this is called the leading coefficient, and it is negative. And basically what that does is it flips the graph. You can also think of it back in your transformations. A equals -1 is a reflection over the x-axis. Reflection over the x-axis. Okay? So that's in blue there. Here in green, you have a third degree polynomial. Third degree polynomial. They call these cubics. And what you want to know from there is that this is a odd degree. Odd degree, right? The easiest one you know is to the first power. All right, something I also notice here is there's no number here without an x. And this would have been the y-intercept. So I know my y-intercept is going to be 0. Okay, so let's construct our own graph. This might be helpful. If I just construct my own graph. let's construct our own graph. Okay, so like I said, the easiest we know is, you know, usually starts down, ends up as you go left to right. But the leading coefficient here is telling me that it's switching. Okay. So we're looking at the blues now. And then a y-intercept of 0 is going to look something like this. Okay. So let me just go ahead and sketch that graph. I don't know, it might look something like this. The big idea is the arrows. Arrows are super helpful. Okay, so and notice I don't have all the other intercepts, the other x-intercepts, but the arrows are super important. Okay, watch. This one has a positive leading coefficient, so I don't need this one or this one. Now this one has negative, I should have done that in blue. This one does have leading coefficients. Okay. So either A or D would be okay so far. And let's see if I can work with it a little bit. Let's factor out a negative x. If I factor out a negative x, I will get x squared minus x minus 5. Okay, what I did, I just took out a greatest common factor. Okay, so what's important in this part I just did is that this has a multiplicity of 1. Multiplicity of 1. How did I know that? Because x here is kind of hard for you to see. Let me see which colors. It's to the first power. Okay, why is that important? Is because if you set that equal to 0, set it equal to 0, and you multiply both sides by -1 or divide both sides by -1, you have x equals 0. And so both of the graphs have it, but you're looking at its multiplicity there. Remember, this is odd multiplicity, which is a shoot through. This is shooting through the x-axis, and this one is not. This one is doing a bounce or a kiss. So it's not D. Our correct answer is going to be A. I actually did this without using a graphing calculator. Okay.
Hey guys, let's go over question number 8. Find the following sum. Sum is addition or subtraction. I'm going to distribute the 7 to each of these terms. Pass out the green starbursts to each of these. So that would be 3x squared. The 7 is positive. 2x. 7 again to the -5. We'll pass out a pink starburst to each of these terms. This 2 is positive. Into this 3. Okay, let's go ahead and simplify this. I'm just going to multiply the numbers in front, so it'll be 21x squared. This would be 14x. -35. Remember, this is multiplication. Common mistake is just multiply the first term. The second one mistake usually is students will try to subtract those. Again, multiply, because there's a multiplication here. If you're stuck with your integers, go ahead and just use your calculator. Let's find like terms. I'll use shapes. Those have x squared. So again, I'm just going to look at the numbers in front. That would be a 19x squared. Nothing there. 14x. And then that will become a -29. And that would be choice D.
Number 9, which function is even? All right, you could you could graph this, but you know, we're meant to do these without a graphing calculator, so I'm not going to graph those. And then this is the problem where it's the star, sub negative x for every x. And basically what this is testing for symmetry. Test for symmetry algebraically, okay? And it wants to know what an even is. So an even basically says that you get the original function, okay? Let's do A. I'm going to put in a negative x for every x value. And here I'm just going to use my order of operations, PEMDAS. So I'm going to use exponents. Negative x times negative x times negative x is negative x cubed. And negative 8 times negative x is positive 8x. And I'm just going to clean that up. So 6 times a negative x cubed is negative 6x cubed plus 8x. Okay, now this one has a negative, so if I factor out a negative 1, this is my greatest common factor, I get 6x cubed minus 8x. And so you recognize that this is the original. So this one's actually the opposite of the original. This one is actually an odd function. So it cannot possibly be A. Okay? Let's try another one. Let's try this one. Oops, I wanted to use green. Let's try g of x. So now, g of x, we're going to put in negative x. And we're putting a negative x for every time we see x. And so 14, negative x to the 4th power is, no. Sorry about that. Negative x times negative x is x squared. And essentially x squared times x squared is going to be x to the 4th power. So it's going to be positive. And another trick that if you're not understanding the multiplying of, they call them monomials, just take negative 1 and put into your calculator to the 4th power. But you have to be careful. You have to use parentheses. You have to use parentheses. Positive 1 is the correct. It's a positive answer. That's what I'm trying to point out. If you did something like this, the calculator actually has read it as 1 to the 4th power and take the opposite. Those two lines are totally separate, gives you the wrong answer. Okay? So use parentheses. Okay. And then this would be negative 3x. So this would be 14x to the 4th minus 3x. And is that equal to the original? It does not. So we can say it's not equal to the original. And so this would not be an even. Okay? Let's try this one, m of x. M of x is this. And every time, again, we see an x, we're going to write a negative x. Now, don't be concerned about the left side. Don't be concerned about the left side. So, negative x equals 9 times negative x squared plus 4. And I'm going to do negative x times negative x, which is x squared. So I have negative x squared plus 4. And that is the original. So you would actually write something like this. So this would be a even. This one up here in green, this was actually a neither. So this one is good. And let's just double check that the other one was wrong. Let's do this one in orange. N of x equals 7x cubed plus 2x squared. And so negative x equals 7 times negative x cubed plus 2 times negative x squared. This would be negative x cubed is negative x times negative x times negative x, which is negative x cubed. And this one is going to be negative x times negative x is just x squared. And if you just clean it up, it would look like that. Now, if you factor out the negative 1, you're going to get 7x cubed minus 2x. It's not equal to the original, and it's not equal to the opposite of the original, because this one has a negative sign there. So this one is a neither. So the only correct answer we have is C. And the last one, end behavior. Describe the end behavior. Remember, as you're doing end behaviors, it always goes left to right. Let's write out a couple tips for you. Left to right. And you always have this sentence frame. As x approaches blank, f of x approaches blank, right? And remember, this blue box is always the same. Always. You have one that's positive. That means as you're going to the x-axis this way, as you're going towards the right, what happens to the graph? And as you go towards the left, the other way here, where's the graph finish? So let's do this with words. As I go towards the right, the graph finishes up. Up is positive infinity. As x goes towards the left, where does the graph finish? It finishes what? Down. Down is negative infinity. Did you notice in red here that these are in opposite directions, which is an odd degree polynomial? Okay? And so if I match it up here, let's see which one that matches it. Positive, positive, negative, negative. That would be choice C. C is my correct answer. I hope that was helpful for you. See you guys.